Welcome to this chemistry course by empowermefirst.college. My name is Claudia Alarcón and I'm going to talk about the introduction to this topic. But first of all, why study chemistry? The great importance of studying chemistry lies in the fact that it's essential for supporting any other kind of science such as physics, biology, medicine, etc. It helps us to understand many things about the world and our surroundings. It allows us to advance in medicine, mining, to improve our living conditions. Thanks to it, we have food conservation and many other things that are thanks to chemicals. Even these feelings of love and stress are thanks to chemicals. But talking about the way they can be applied to our life, we can see all these benefits of chemistry in our daily life. For example, with food, we can see that in the little label, we can see a lot of substances developed by chemists, especially to preserve them, to maintain their flavor and their properties. Chemistry is also present in cleaning and bathroom products, in dyes, on our clothes, and of course in medicine, beauty products, and technology like the one we're using today to watch this class. But also, it is present in all the educational programs, and that's why we have to at least know the basics of this science. How do we define it? Chemistry is the science in charge of studying the compositions, properties, and structures of material substances. And the birth of this branch of science goes all the way back to the beginning of life and humanity. Did you know that Egyptians laid the foundations for this term? Because the word chemistry comes from chemi or chem, which means earth. And it's because it studied the composition, structure, and properties of matter, like we said, and all of these changes undergoes chemical reactions. Historically, modern chemistry is the evolution of alchemy. Alchemy was people trying to obtain gold out of anything, and it was the first start of this chemical revolution in 1733, and it has been developed to our day and age. Let's talk a little bit about history, and how chemistry has been present all over civilization. As man has been inspired by the search of answers, explaining matter transformation. In ancient times, we can see examples in the paintings created by the Egyptians, which had pigments that were purposely altered to have different colors. This also happened in the blue bricks of ancient Babylon, and this is very hard to replicate even today. And the last example are the frescoes of the classical Greece and Rome, and all of them still bear a mysterious relationship to modern chemistry, even though it was years away of today's technology. But these pigments were intentionally made by experts 1,000 years ago. That is pure chemistry. But we can see other examples, like the invention of soap 2,800 years before Christ. The ladies there realized that they needed something else to wash the clothes, and they synthesized a kind of soap. This is stated in the tablets of Mesopotamia. These are the clay tablets where they wrote their history, and we can see that they actually used soap. And we take it for granted now, but it was clever to do it. And the last example is the invention of fermentation by China 9,000 years ago. And this has allowed us to have wine, beer, but also food conservation, medicines, etc. Well, chemistry, as you can see, is a basic science. Why? Because it's essentially empirical and it studies things through the scientific method. That's it, like through observation, quantification, experimentation. And the ubiquity of chemistry in natural sciences means that it is considered one of the basic sciences. being of great importance in many fields of knowledge, and that is why it's important to understand it, because we will find it everywhere. We breathe thanks to chemistry, we hear thanks to chemistry, we move and understand the world thanks to it because of the brain chemicals, and it's everywhere. That's why it's important to know about it and all the types of chemistry, because there's not only one kind. Let's talk a little bit about this. Traditionally, chemistry has been broken into 5 main disciplines: organic, analytical, physical, inorganic, and biochemistry. But let's talk little by little. Organic chemistry studies the molecules of life. It is mainly considered with looking at the structure and the behavior of these molecules, which are composed of only a few different types of atoms: carbon, hydrogen, oxygen, nitrogen, and a few of others. But if something has these 4 chemicals, it's considered about organic chemistry. But don't worry, we will talk further about it in other units. Another kind of chemistry is the analytical chemistry, which focuses on the identification and quantification of materials in a mixture. Analytical chemists may invent procedures for analysis, or they may use or modify existing ones. They supervise, perform, and interpret the analysis, and this takes a lot of measurement, weighting the chemicals, and understand the behavior to analyze, right? We have also physical chemistry, which studies the fundamental physical properties that govern the way that atoms, molecules, and other chemical systems behave. Physical chemists study a wide range of topics, such as rates of reactions, which is called kinetics, the way that light and matter interact, which is called spectroscopy, how electrons are arranged in atoms and molecules, which is called quantum mechanics, and also the stabilities and reactivities of different compounds and processes, called thermodynamics. You will learn more about it in the next units. But what's the next type? It's inorganic chemistry. It is commonly thought as those areas within chemistry that do not deal with carbon. However, carbon is very important in many inorganic compounds, and there is a whole area of study known as organometallic chemistry that is truly hybrid of the traditional disciplines of organic and inorganic chemistry, but that's a little bit more advanced to understand, so don't worry. Some areas of inorganic chemistry are especially important, like catalysis, materials chemistry, and bioinorganic chemistry. The last type of chemistry is the biochemistry. It studies the chemical principles underlying basic biological systems. Fundamentally, biochemical research aims to characterize the link between the structure and the function of biological macromolecules. More specifically, biochemical research has provided a more comprehensive understanding in regenerative medicine, infectious disease, organ tissue transplantation, clinical diagnosis, and genetic disease. Even though we talk about 5 types of chemistry, over the last several years, additional concentrations have begun to emerge, including nuclear chemistry, polymer chemistry, biophysical chemistry, bioinorganic chemistry, environmental chemistry, among many, many others. There are a lot of new areas of chemistry now. I would like to finish saying that chemists are not only in the laboratory, but we can be also behind supercomputers doing theoretical chemistry or any other kind of chemistry. It's not only to be taught in, with our lab coats in the lab. Chemistry goes all the way to a lot of areas, even touching business, and areas that you would thought that chemistry is not there, but you can interact if you know the principles of this area. There is so much to discover, but we need to learn the basics first. In this chemistry course of Empower Me First College, you will learn the fundamental topics and acquire the knowledge you need to achieve your degree. Well, are you ready for more? I'll see you in the next video talking about the kinds of matter and a little bit more about how the movements of the atoms or particles behave. Let's keep learning, and I wish you the best. See you in a few seconds. Ciao.